All right, guys. This is the second part of the lesson for today. Um, the last video, it was rule number one. If you take the square root of a perfect square, it's gonna be a rational number. If you take the square root of a non-perfect square, it's gonna be irrational. We're gonna use that idea for this one. Now, this part is what happens when you add a rational number with an irrational number, or what happens when you subtract a rational number from an irrational number, or vice versa. So I came up with rule number two. Rule number two is if you add a rational number with an irrational number, the sum is generally going to be irrational. All right, so let me give you an example. So if I do 3 is a rational number, it's an integer, and the square root of 2, since 2 is not a perfect square, we know that this is going to be irrational. So we're adding a rational number 3 with an irrational number, square root of 2. When we add those two numbers together, we're going to get another irrational number. Now, the easy way to check this is go to Desmos, key this in, 3 plus the square root of 2. If you see something that has a bunch of decimals that don't have any repeating pattern, then you know that's going to be an irrational number. But whenever you add a rational with an irrational, you're going to get an irrational number. So look at the second example. So this one would be irrational. Now, 4 plus the square root of 16. What you should see is that this 4 is a rational number, but this right here is a perfect square, so this is also going to be a rational number. When you add two rational numbers together, you can only get a rational number. So this one would be, so even though this has a square root, it's still a rational number because this is a perfect square, okay? So that's kind of a trick. So you should always be looking for perfect squares whenever you're doing any kind of trying to determine whether something is rational or irrational. You should be looking for perfect squares. Now, the last example is another kind of no-brainer. Whenever you add two irrationals, you're going to get another irrational. So this 3 is not a perfect square, so this is going to be irrational. 2 is not a perfect square, so that's going to be irrational. So when you add two irrational numbers, you can only get another irrational number, okay? You can't add two irrational numbers and then get rational. The only exception is this. If I have a square root of 5 and I add that to a negative square root of 5, okay? So basically I'm just adding opposites. This is going to be equal to 0, and 0 is an integer, so that means it's a rational number. That's the only way that you can add two irrational numbers to get a rational numbers. They have to be opposites, but that's kind of a fluky one. So that doesn't happen very often. So generally, this rule is true. Whenever you add a rational with the irrational number, you're always going to get irrational. When you add a rational with another rational, you're generally going to get irrational. The only exception is when you see something like that. Okay, so that's the first rule. Now, it's kind of a similar idea for when you're multiplying or dividing. So my rule for this one is if you multiply a rational number with an irrational number, you will always get an irrational number. Unless the rational number is 0. But if you multiply any number other than 0 by an irrational number, you're always going to get another irrational number. So 4 times the square root of 5. 4 times the square root of 5. This is rational. This is irrational because this is not a perfect square. So the answer is just going to be 4 times the square root of 5. I know that that's going to be irrational because this is irrational. Okay? Same thing. 2 times the square root of 8. This is rational. This is irrational because that's not a perfect square. So my final answer would be 2 times the square root of 8. I know that that's going to be irrational because the square root of 8 is not a perfect square. Okay? Now, where you have to be careful is when you're multiplying irrationals together. So let's look at this first example. 2 times the square root of 3 times the square root of 8. Is that going to be rational or irrational? Well, what you would do in this example, I'm going to use red, is this would be, you would take what's inside the square roots and you can multiply those together. So this is going to be 2 times the square root of 24, because 3 times 8 is 24. And what you should say at this point is 24, is that a perfect square? No, it isn't. So this is going to be irrational. So all you do when you are multiplying two irrational numbers is look at what's in the square roots, multiply those things together, or if it's division, divide those things together, and see if when you divide them or when you multiply them, you get a perfect square. If you do, then that's going to be rational. If you don't, it's going to be irrational. Let me give you another example. This one, second one. It says 2 times the square root of 8 times 4 times the square root of 2. Is that going to be rational or irrational? Well, the 2 times 4 is going to be 8. And then we're going to take inside the square roots, it's going to be 8 times 2. 8 times 2 is 16. Now, the question that you guys should be saying is 16 a perfect square? It absolutely is. So this is actually going to be 8 times 4, and that's a rational number. So when you are multiplying irrationals together, you have to check the square root part. If that's a perfect square, then the overall thing is going to be a rational number. If it's not a perfect square, then that means it's going to be irrational. Okay? So we're going to go through, I'm going to give you some practice, but basically that's what you need to know. Whenever you're adding or subtracting, when you get done, whatever your result is, if you still have something that's not a perfect square in the square root part, then that means it's going to be irrational. All right, guys.